South Africa has one of the world's highest burdens of drug-resistant tuberculosis. And one of the reasons that this is so is the way that we as physicians treat patients.
We've witnessed a number of revolutions in modern science. I consider myself young, but things are done dramatically different in 2012 than they were when I was in my training in the 90s.
When a patient comes in and we suspect that they have TB, we'll take a sputum sample from that patient and send them home. They'll return for a follow-up appointment after we've looked at that sputum, and then we'll diagnose them with TB and give them medications and send them home again. They'll come back a third time. We'll assess the success of those medications. If those medications failed and that person's not doing well, we'll then change them. The problem with this workflow is that we won't get around to giving them the right medications until they've experienced a treatment failure in that person. And the clinical problem is now this person's personal health has suffered. And they've also developed drug-resistant tuberculosis, and they've also likely spread that to other people.
We seek to use the strains that are afflicting South Africans with TB, multi-drug-resistant TB, and extensively drug-resistant TB, MDR and XDR TB, and study those from a genomic point of view.
So we've identified a need in tuberculosis treatment and research to have a tool that can more accurately predict the resistance a person will have before we have to watch them fail treatment. So what we decided to do at K-RITH is to create a database of whole genome sequences of tuberculosis collected from real patients in KwaZulu-Natal. And through cooperating with several clinical sites, we've begun putting genome data in this database we've built, as well as the clinical records from these patients that we've seen. And we're now amassing a track record of which patients succeeded and failed which medications, and the sequence of the DNA of the TB that they carried.
We feel that we have a golden opportunity to collect the genomes from patients in this area, put them through genomic analysis, and begin to understand the sequences that will predict outcome.
Our hope for this tool is that a clinician, when they see a person whom they suspect has TB, will take that sputum sample and send it directly to a sequencing center.
A patient could come to the clinic, give a sample, and know within a day or two or even a few hours whether treatment A would be needed or treatment B.
So you can give them the right medications the first time and avoid the development of drug-resistant TB altogether. This is the grand vision of the database that we're making. Amazon Web Services, namely, has been the backbone of our current database. We've put much of this information in the Amazon cloud. Along with this, we're also adding computational capacity to our web portal so that researchers can contribute in a collaborative space working with us to analyze the data that we share. And this will make it more efficient for everyone involved.
And that day is really on the near horizon, and I know that K-RITH is going to be a strong contributor to that.